Alrighty, so we're looking at chapter 12, which is modules. And actually, we're just going to look at two of the modules. We're not going to worry about making our own and things like that. I think for an introductory course, just understanding that there are modules and getting a couple that are definitely useful to us. So the first is random numbers, and definitely for doing simulations and that sort of thing, random numbers are very important. And so to use a module, to use all the pieces in it, we import that module, and you have to know its name, and you can often go to Google to try to figure out, is there something you want in Python, and that'll lead you to some module usually, and then you can see examples of how to import it. So here we're going to import random, and I've already done that. Here, import random. Now we'll see that we can do things with a little bit less typing as we go. Excuse me. Okay, so here what we'd like to do, so I'll just come down a little bit. So I import random. Now, what can you do with random? Well, I've got some links here. Yep. So in the module 12 page, I have some links. And here's the Python page for the random module. Here's the W3 schools page for the random module. And so you could use either of these, and I've got them both up. And the W3 schools is probably more user-friendly, but it is not necessarily up to date, and so you want to be careful about some things there, and we'll see something right off here. So if I go to the W3 schools and I ask, what kinds of things can I do? Well, so here's this rand range, returns a random number between the given range, and then rand int returns a random number between a given range. Well, they seem to be saying they do the same thing, but they both say number. Well, int sounds like it would be an integer, and so that's where you have to be a little careful. This isn't extremely clear. Now you could click on them and get more information, but if we go to random here, this is set up. It's got links here to the side to get to things. So it starts with bookkeeping functions. We'll come back to that. Here's functions for integers, and so for instance they mention rand range. You can do a start and stop value. You can step by something here and all that. But as you look at this, some things you should look for are things like this word deprecated. Here they say changed. So deprecated means it may no longer be available to even use. They stopped supporting it at some point, and you'll at the least tend to get a warning message that says the command is deprecated. This so for right now, I guess if you said rand range 10.0 and put a float in there, if you were in version 3.9, it wouldn't give you an error, it would just do it. But now it would tell you there's a type error because you should have an integer in there. And then it says more deprecation. So you just it's good to see this. But notice rand int returned a random integer n such that a is less than n, b n less than or equal to b. And and it says alias of rand range of a and b plus 1. So what randint doesn't do is it doesn't allow you to put in an optional step size. You know, like if I only wanted to do odd numbers or only even numbers or something like that. I can't do that with randint. But what I do gain is if I say I want a number between, say, 1 and 10, and I mean I'd like to have 1 and I'd like to have 10, I'll get both of those. But up here, the stop is not actually where you stop. If I wanted to stop at 10, I mean truly have 10 in there, I would need to do an 11. So let's you know, just try that. And so we'll do something very simple. I'll use a 0 and a 1 for rand range. So I'm going to come here, and so if I say oh, I don't know, r equals, well, let's just do a print for now. Print and you say random dot rand range, and I'll say from 0 to 1 and print that. But now I'll do print random dot rand int, also from 0 to 1. Okay, so and actually let's do this just to make sure you kind of see what's going on. We'll do for I in range, so we'll do each of these 10 times. Range 10 colon that, and then that in the right spot. That in the right spot, and then I'll put an empty print command so we don't get, so it doesn't make it too hard to see. So we'll do that and get these 10 random numbers, but they both say between 0 and 1. So you might, if you do the rand range, so we'll go back here, let's see, we'll go to this one. Okay, so we had rand range, we had randint. So if you do the rand range, you might think that you should get zeros and ones and all that. So let's run this. Notice now, you know, we got 0 on the first one, 1 on the second, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, and finally 0, 1. And so you see the first one, the rand range, only gave us zeros because it stopped one below what we had here. And whereas randint stopped at the 1. So, you know, those are just little things you have to notice and look for. But on the other hand, you know, what's nice is if I, you know, took this up to 11, so I got numbers between 0 and 10, but I could do a step size of 2, so I should only get even numbers out of that. And I'll do a 0 to 10 here. I could get odd numbers out of this one, and so if we run that, so you see 4, 8, 10, 2, 2, 10. So I'm only getting even numbers out of that first number, but I'm getting both even and odd numbers out of the second number. Okay, so I can generate a random number uniformly. So in other words, the number 4 up here has as much a chance as 0 or 2 or 6 or 8 or 10. 9 down here, that 9 has the same chance as 0 through 8 or 10. But that's just, those are particular random pieces. Now I'm going to just do it once just to shorten up the whole thing. Now, it would get old, I think, kind of typing this random all the time. And so what you can do, instead of say import random, you can actually give it an alias. And so you could say import random as rn, so here I could just make this now an rn and just make that rn, which just makes it easier to type. So now I should be able to run this, and there we go. So it ran just fine with just the rn. So you can do that, or I can do something like from random import rand range. Oops. Rand range, comma, rand int. And we'll comment this one out. Oops. Okay, so now in this case, I believe I should be able to even get rid of the rn here, because now it knows what those are. And you might do something like this if the module is really quite big, but you really only wanted a couple things from it. And let's see if this will run here this way. I think it does. Yep. See, so now I don't need the rn in front of it. So a lot just depends on how many of these you're going to use, whether you want to do it this way. I would suggest either you just pick what you need if you only need 1 or 2, or you do the alias here and do the import random as rn, something like that. So actually, so I'm going to do that, and comment that one out, put the rn back in here. Okay, but those are different ways you can import something, and any of the 3 is fine. It's just kind of what you want to do. But again, with some of these, if the module name's kind of bigger, it gets pretty old doing that. So there, we've got that one. Okay, so those are a couple things you can do with integers. So we can create integers. Now I can also, I'll insert a cell here. And just to be complete, even though this remembers that I had imported this, I'll just add it to the cell here. So we can go here, and so that was integers. Now they've got bits and so forth. We don't care about that. Now let's just let's see, real valued distributions. Okay, so you might want to do things just with integers like I did, or real value distributions, so you might want real numbers, and there's a bunch of these. Now notice it's random.random gives you a floating point number in the same range. Uniform gives you a uniform floating point number, and in here now see, that's using an n, but that should be a floating point number, so we'll check both of those. So we'll do kind of like we did with the int stuff. So I'm just going to copy this, and I'm going to place it here, but now I'm going to use random. Okay, so there's the random, and it only takes 2 arguments. So now let me look back at it again and see. So it's a uniform distribution. It says here it doesn't take any arguments. Okay, so actually I'll have to remove that, and it says I'll get anything from the actual value 0 up to some floating point number less than 1. So it's saying here I better take out the arguments here. So I just do it like this, and I should get a number between 0 and 1. And now let's do uniform. And what this allows is to have other values, but I'm going to try 0 to 1. Now let's look back at this. Now here it says it will give me a number between A and B, but less than or equal to B. So actually this command with a 0, 1 is very slightly different than this one, because out of this command you would never ever get a 1. But out of this command you could if you put in 0, 1. Now, how likely am I to see it? Probably not 2, because there are a lot of floating point numbers in there. But nonetheless, let's run that one. And so you see in both cases we got a floating point number between 0 and 1. But again, here I could change this to say a 2 and a 4. I lost one of my parentheses there. So I could do a 2 and a 4 and run that. And so you see I got actually very similar numbers on the decimal part. And we'll look at some things there in a moment. But that's something similar to what we did up here, but now we're talking about floating point numbers. Now, however, there are lots of different ones. So a triangular distribution, what that does is, I don't have things set up to draw here, but if you draw the x-axis and you draw a triangle over it, over top like this, then you'll get a distribution of random numbers. That you get more random numbers that are around the x value that goes with the peak of the triangle, and very few at the ends. There's the beta distribution, the exponential distribution, the gamma distribution, so you can generate all of these sorts of things. The Gauss distribution, which is says slightly faster than the normal variate. So a Gaussian distribution is just a normal distribution. And maybe this one was written later than this one down here, because it looks like it's exactly the same. You give it the mean and the standard deviation. There's a log normal distribution, a von Mises distribution. Now, I don't even know what that is. I have no idea. Pareto distribution. Actually, I know what a Pareto solution is to something, but I'm not sure what that is. A Weibull distribution. That's a very nice, convenient distribution to use. I've used that for some things. Okay, so, there's lots of different random distributions that one can choose from. And so, that's kind of the real value distributions. Now let's look at this thing, functions for sequences. Okay, so if I have a sequence of things, which, here, that sequence, well, where's an example? I don't know that I see an example. I'll have to go down, but I can just make a list, okay? And so I could do a choice from that list. And so let's make a quick list. Yeah, let's use this. So I'm going to make this list of red, blue here, just the two numbers to start with. So, or numbers, two words. So again, I'll insert something down below. Again, I'll go ahead and say import random as rn. Actually, don't truly have to here, because it remembers. But let's see, so I have that, and then enter. Now I'm going to let my list L equal the red blue. Oh shoot, I forgot. Let me go back here and copy that again. Silly me. Oh, that's not where I got it, was it? It's right here. Okay, Control C. Control V there. So there's red, blue, and then if I I'll just do a well, again, I'll do a for loop. Okay. And so this time, let's look at, so we have choice. Oops. Okay, so we have choice, and I pick something from the sequence. So let me do choice. Okay, choice. And I need to tell a choice from what, and that would be the L. And I'll do this maybe 5 times. Okay, and then, though, I want to compare that with so down here, notice it says sample, and return a k-length list of unique elements. Okay, so I have to give it L, and I guess I need to give it K. Let's see, so there's sample there. The star, I don't know what the heck that is. But notice the K, I say K equals so the number of times I sample. Okay, but notice this says unique, so it's without replacement. So let's look back at choice. It can only pick one, but if I go to choices, I can have it pick more than one. So that's what I'm going to do. I'm going to have it pick two. So here I'm going to use choices. And I'm going to put in a comma and say k equals 2. Try that. And then here I'm going to do the sample. And again, I'll do the same inside. So the sample from L and k equals 2. We'll see how that does. So let's try that. And we're going to do this 5 times. Oh, invalid syntax. What do we have there? Oh, I've got two parentheses on there. Okay, let's try that again. Okay, so notice the first time we got red, blue, blue, red. Okay, and then, you know, and so they look like they're sort of doing the same thing. But notice down here I got blue, blue, then I got blue, red, 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 blue, blue, red, red, blue, blue, red, red, blue. So the second one with the sample, it said without replacement. So there were only two elements in there, and so as it chose them, if it chose blue first here, then it could only choose red the next time. So it did that 2 times, and then 3 times it chose red first, and then it could only choose the blue. But for choices, I could get blue and blue, or red and blue, or red and red, blue and red in that order as well. But I could get both the same color from choices, because that as you look at it, it says with replacement. So this says with replacement here. So in other words, it picks something out, looks at it, and then puts it back. And now you can actually give it, I guess, cumulative weights, so that if weights is specified, selections are made according to relative weights. So you know, 10 compared to 5. So I guess you know, if I had something of length 4, you know, so 4 items, then you know, if 5 was the base, then the first thing would be twice as often as either the second or the fourth, and the 30 here would say 6 times as often as those. So I guess that's how you would use those, and you would say something like weights equal and something like this. So let's try that just even with our 2. Let's try weights equal okay, so I'll put this in here with a comma, and then weights equal, and let's give it something outrageous. So red comes first, then blue. So let's make it like 10 to 1. So 10 comma 1. And so let's run this again. Red, red, blue, blue, red, 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 red. Now I'm really actually kind of surprised at the blue, blue. Let's do this 10 times. Just because it shouldn't happen very often if I've got the weights working correctly on but certainly rare things happen. So, yeah, this time, right, red, 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 red. Another blue, blue, so that was interesting, but then red, red, and then red, blue. And, so definitely red was coming up way more often than blue. And if we did it 1,000 times, we could check to see what we ended up with there. Okay. So, so we have that sort of thing, and actually there's something similar here with sample. Sample, you can do accounts, and so repeated elements can be specified. So here they do counts, and so let's try that same counts equals, we'll try a 10 and a 1, so there'll only be one blue again, just to kind of see what happens with this one. This one said weights. Now we're going to say counts. And we'll do 10, 1. Okay, so again, there are 10 times as many reds as blue. Oh, what happened? Sample got an unexpected keyword counts. Is it count maybe? Did I read that wrong? Counts. Well, it says that works. Ah, wait, deprecated. That must be a sequence instance of set or no. Changed in version 3.9. Well, I wonder if I'm using a version earlier than 3.9. That could be. Let's see, version. I don't know if I can check that simply by coming down here. Cell below. I don't know what happens if I say print version. I don't remember how you get the version out of it. Let me try running it. Name error. Yeah, see, it's so what you can do is you can go to Google, and that's how I found the modules. And you could say, oh, what's the Python version? Version history, documentation. Well, that's how to check your version there. Okay, let's go back to here. Let's see if there's one that you can do while you're in Python. Let's see. Okay, check the version of Python. Oh, that's Linux. Okay, check. Okay, so that's yeah. Okay, so yeah, I can do it, but I'm not going to do it right now. So the best I can tell is possibly I don't have a late enough version, so that could be the problem. If that's the case, I can't do this. I'll just have to check, and I can send it in an announcement or something, or come back to it. What's going on here? Oh, that's my error. Sorry. I wonder it didn't want to get rid of it. Ah. There we go. Okay, so I couldn't do that. So it looks like it's, oh, nice. Yeah. So I wasn't able to do that, and you know, so I can do this, and then I can just get rid of this thing here. Okay, let's see. Now shuffle. Again, I'll import, and like I say, you know, in the notebook, once I've done it once, I don't actually have to do it, but just to, you know, kind of remind you that I do need to import it at some point. So let's do that. And now what I'm going to do is I'm going to make a list. I'm just going to make that equal, you know, say range of 10, so it'll be 10 numbers 0 to 9. Now let me print that. Okay. All right, let me run that. Oh, yeah. How do I do that? See, I got to remember back to lists with that. Go back and look it up if I have to. But let's see. Do I just do it that way? You can tell me. Just shout. No. True. Huh. Okay, so silly me. Okay, let's go just back for a minute here. So you see, you know, I try to point out that I don't remember everything. You know, I have to go looking things up at times. So I'll bring the module back up there, but not sure why this is going so slowly tonight, but so list values, let's get our range, accessing elements, list length, list membership, list operations. I thought they showed us how to do this. Well, I guess maybe that's why I don't remember how. They don't. They didn't actually show us in here. Well, they did, and I'm very sure I can make that list using the range command. But they never told us that, I guess. So, okay, well, so much for that. No wonder I couldn't remember from there. Okay, so we'll just do it the old-fashioned way. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Take that space out to make it look the same everywhere. Okay, so let's run that. Okay, so we've got 0 through 9 there is our list. Now I'm going to use random shuffle. So, and I'm going to do it twice. So print um, rn dot shuffle L like that. Now, and then I'm going to check something. So print L. Right. So the question is, when I do the shuffle L like that, did it change L? And so let's take a look. Where am I going? Oh, yeah, right here. Oh yeah, okay. So let's look at shuffle again. It may not have any output. Yeah, okay. So let's find shuffle. Whoops. Shuffle. It says they got rid of that optional random parameter. And it shows you if like you wanted to shuffle a string, you would need to do it this way. So yeah, it appears they don't say it here, but yeah. Oh, there we go. Shuffle X in place. So they actually overwrite your list. Okay, and I was thinking they did, but I didn't point that out here. I sort of didn't notice it again, but notice, see, so it changed your list. So if you don't want to change L, you probably need to do something like, well, how about M equals L dot copy, and then now we aren't going to print this anymore. We're just going to do the shuffle, but we're going to shuffle M instead, and then we'll print M. And L. So let's see how we did here. Okay, so you see we left L alone, but M was different. And so now let's take these three commands and we'll believe that L's fine, so we won't redo it. But we'll redo those and see we should get a different shuffling of the numbers here. And you see we do. Okay. So, you know, shuffle is a nice way. These are permutations of whatever my list is. Thought it was easiest just to do with the numbers. Okay, now I want to show one more thing using this, and that is at times you may want to do some work with random numbers and that sort of thing. However, you might want to reproduce exactly what you had done sometime before for some reason, right? In other words, these are pseudo-random numbers. They're not really random that we're making. This isn't really a random shuffling here, not truly a random shuffling. And to kind of show that, let's go here, and here's the bookkeeping functions. And in particular, here's seed. This, if I don't state this seed, then Python will just kind of create its own, and it will start making its its seed on its own. Now let's see, I do need to look at versions. Okay, with version 2 it says that's the default. A string bytes or a byte array objects get converted to an int and all of its bits are used. Okay. If A is an int, just use it directly, it says. And then with version 1, and this is for older versions of Python, so let's try just omitting the version 2, and it looks like I should just be able to say, instead of A equals, I think I can just say the number. And often, some big number is fine. So what I'm going to do is we'll do it before we shuffle. We'll do it right here. And we'll say rn dot seed, and we'll use the number I don't know, like 23,579. Okay, so that's our seed. Now we run this, and you see I got two different sequences in the second and fourth here. But now let me put this same command right before here. Okay, so I've set the seed to the same number in both cases. And you see I got the exact same shuffle. So if you have a big code where you're doing a bunch of random things in a row and that sort of thing, but you would like to be able to reproduce that exact set of pseudo-random numbers, you just probably right at the beginning of your code you would set the seed like this. Alrighty, so I think that's what we'll do for that's plenty, I think, to talk about with the random module. So we'll stop there.